Yep. So now let's do a little exercise. So consider a watch with two buttons. Press both buttons simultaneously to enter a set time mode. And watch blinks the number being changed in a sequence of hours, minutes, seconds. Press the first button to move to the next number. Press the second button to increment the value. So press both buttons simultaneously to set the time. Then this is the problem statement. Then I will give you 1 minute to draw a class use case diagram. Just for this simple watch. So imagine that I am the customer and I give you the description, then a problem statement. So based on this, you should have the capability to work out a use case that shows the function provided by the system.
The sequence of hour, minute, seconds.
Watch blinks, the number being changed. So in the sequence, so if you press one button, then it is hour starts to blink. If you press again, minutes start to blink. If you press again, seconds start to blink. In that order. Then if you press the second button, then you increase the value, the corresponding value. In use case diagram, you only have actor use case. Because the purpose of use case diagram is to show the functions. So if you see the use case diagram, you know what functionality is provided by the system. So it doesn't show any sequence. So you cannot show the sequence of hours, minutes, seconds. Also, I put it here, but not every single detail can be reflected in your use case. It only shows the functionality of the watch. So your attention is on the functionality alone. For example, although I say that watch blinks in the sequence of hours, minutes, and seconds, but you cannot show the sequence, or you cannot show the order using the use case diagram. Because use case diagram is only used for functionality. So you can only show the functionality of the system.
So you're doing a use case diagram?
Yeah, so you just use use case diagram. So in use case diagram, you now we only studied two major elements, just the use case. I don't know. Yes, the use case and the actor. Only two things. Yeah, so later we will have the third pass. So we will study that. What does a use case mean? What does a use case mean?
It has user and actions performed by user.
So yeah, so use case represents a class of functionality, right? That's a class of functionality provided by the system. So then you can discuss with your neighbors, and you guys can discuss, and you can come up with a solution. So for example, if you put clock button as a use case, this is wrong, right? Because these are objects, these are not functions. Yes, it's something like this, set time and stuff like this. So you just want to show what kind of functionality is provided by the watch, or what watch can do. Okay, so let's do it together. So the solution is not unique, but normally we can just we can read time. We can put display time, then we can set time and change battery. So this part is not illustrated in the description. So this part is fine. So if you just put display time and set time, then that's fine. So you see, we have such a long description, but you need to summarize and ignore the irrelevant details and just summarize and make abstractions. So basically, if I give you a watch, you can set time, it can display time. So that's it, right? Then definitely you can change battery. Later I will add something, you can add battery. So basically, a use case only consists of actors and use cases. And you cannot show the order of the operations. So I'm not sure you have noticed that I posted the first individual assignment. Basically, the idea is, this is an airline company considers constructing an online flight reservation system. The customers can purchase tickets, change reservation, cancel reservation, and view itinerary. If a customer prefers to make phone calls, the customer service representative can use online system to help the phone user to purchase tickets. So basically, the customer service representative can do the same thing. And customers are supposed to use credit cards to pay for their reservations. Then the reservation system will check the credit with the credit system to validate the credit card information. So this is to make sure that a valid card number was entered and that the credit amount has sufficient funds account. So however, for change reservation, the system checks credit if and only if the amount of the reservation has changed. If the amount has no change, check credit does not need to run. So basically, this is the description for the problem. Then first, you need to draw a use case diagram for the above statement. And here, so you need to prepare the textual description for the use case of purchase ticket. And third, you should answer the question, if the customers can be further categorized as individual customers and corporate customers, how can you raise your use case, revise your use case diagram to reflect such details? And, you only have 3 questions. So if you do it carefully, you can finish in 2 hours. Then for the use case diagram, I would require you guys to use a UML tool. So you cannot use your hand to draw it. So you need to learn how to use a UML tool to work out the use case diagram. So do you have any questions for the homework? Okay, or you haven't even looked at the homework yet. Okay, then probably you guys will have questions on next Monday, hopefully. If you still don't have a chance to look at it, then probably you don't have time to finish it. So this homework is pretty straightforward. So you see, this is a textual description for a while use case. Okay, so this is second pass on UML diagrams. So next, we will proceed to the class diagrams. So class diagrams represent the structure of the system. And the class diagrams can be used during the requirements engineering phase. So we can use it to build up the classes. We call it analysis classes on the application domain. Then we can use it during the system design to model subsystems. Then we can use the object design to specify the detailed behavior and attributes of classes. So for example, we may have a class diagram like this. So it models many-to-many relationship. So when you see asterisk, it means 0 or more. So tariff schedule may be associated with 0 or more trip. So a trip may be associated with 0 or more tariff schedule. So a class represents a concept. So now remember that we studied concept, right? Then if a class represents a concept, then an object represents phenomenon. Very good. So the class name is only mandatory information. And our class encapsulates state which are achieved through attributes and behavior achieved through operations, for example. So this is a UML class symbol. So it has name, it has attributes, and it has operations. And the name is only mandatory information. So each attribute has a type. For example, this is tariff schedule and zone 2 price. It has a type, which is table. So every attribute has a type, and each operation has a signature, right? For example, price, get price, zone, the return type as well as parameters make a signature. Then, so far we have studied the actor, class, and object. So what's the difference? So what's the difference between actor and a class? So actor and class are similar, right? So an actor. So what is an actor?
Class name.
Actor.
An outside entity, external entity.
Okay. So an actor represents. Actor represents
A role.
a role. So an actor represents a role. For example, professor. Professor, is not a particular person. For example, Dr. McDaniel is a professor, right? But a professor is a concept. So, it is a role, right? So an actor. Then class is also a concept. Then what's the difference between actor and class?
Class will show their attributes and operations, like their structure.
Mm-hmm.
Whereas the actors only
Actor
shows
is
their
specific.
It's like a,
how they use the system.
Okay.
it's like a blueprint.
Well, blueprint, yes, class is. Then actor can also be a blueprint.
Actor is specific, whereas class is not specific.
Actor represents a role which can be also very abstract. For example, just like a student, right? So student is a general term. Now you guys, each individual is an instance of the student.
Attributes of actor can be shown in class, like the or specific behavior of that actor and the different types of actors.
Okay.
All this can be defined in classes.
Actually, actor itself can be a class, right?
Yes.
Yeah, for example, professor, student, these are actors, but they can each represent a class.
Or else is it like actor is a concept that class is a phenomenon? You
Okay.
can say that, right?
So in other words, actor is an entity outside the system to be modeled, right? So interacting with the system, for example, passenger. So passenger is an entity outside the system. So you won't build a passenger. So you don't implement a passenger. So passenger is an entity outside the system. Then class. Class is an abstraction modeling an entity in the application or simulate a solution domain. So the class is a part of the system model, for example, user, ticket, distributor, and server, and so on and so forth. Is that clear? So actor is an entity outside the system. It can be a class, but you don't implement it. The object is a specific instance of a class. Yes, just as you guys mentioned. So class is a blueprint, and the object is a instance. Or class is a concept, and object is a phenomenon. So now we see instance. So instance represents a phenomenon, and attributes are represented with their values. Now let me give you another example. So for example, we have a class, we call it student. A student has the attributes such as age, GPA, then for example, for academic year, for example, things like this. So this is a class, right? Then if I give you an instance of student, so it can be Tom. So Tom is an instance of student, and Tom's age is 18, and GPA is 4.0, and academic year is, for example, junior, and so forth. So is that clear? So an instance of the class. So then the attributes are represented with their values. So the attribute age is represented by the value 18, GPA is represented by 4.0, academic year is represented by junior. So is that clear about the relationship between class and instance? Okay. Then the name of an instance is underlined. So in the future, if you see a name is underlined, it means an instance. Then the name can only contain the class name, or the name doesn't include the name of the instance. So this is called anonymous instance. For example, in this case, it's okay. We only have the class name. So the class name is tariff schedule, but it doesn't have the instance name. So this is an instance. This instance is called the anonymous instance.
Means we can write any name there, right?
You can write any name. So you can give A, B, C, D. So it doesn't matter. So it's just an instance. Just for example, just like a student. Student is a class. Then the specific student can have any names with Tom, John, Peter. So these are this name of the instance. Now associations. So when two classes are connected or have some relationships, then associations is the most widely used relationship. So it means that two classes are associated with each other. So this is many-to-many relationship, right? So a tariff schedule can be associated with many trips, and a trip can be associated with 0 or more tariff schedule. And these are called multiplicity. And multiplicity is put to the end to denote how many objects of the instance of class can legitimately reference. So for example, we may have one-to-one relationship. So a country can have one and only one president. So a president can serve for one and only one country, right? So it's going to be terrible if a president can serve more than one country, right? So country and the president has one-to-one relationship. Then a polygon may have how many points?
Multiple.
Any number of
0 or more, right? So it can have multiple points. Then a point can belong to one. So if you don't say anything by default, this is one. So a point can only belong to one polygon. So this one-to-many relationship. So we have studied this, so many-to-many associations, and I mentioned that we can automatically generate code from the model. So now let me show you. Okay, so let me create classes. One is called company, right? So one is called company, and the other ticker symbol stock exchange. Let me add a new attribute. So it's called ticker symbol. And if you right-click it, you can change the attributes. For example, ticker symbol, we can put a type to be int. Then we can create another class, which is the stock exchange. And we can put the relationship. It's many-to-many, so this association, if I double-click it, let me change the multiplicity to asterisk. Asterisk. Okay, so this is many-to-many, right? So this is a platform-independent model. So it doesn't rely on any particular platform. So now I'd like to generate Java code. So if I select both and select tools and Java, here it has generate code. The code will be generated to C temp. Okay. So now we go to okay, now you see two Java files are generated. One is called company.java, the other is stock exchange. So this is generated code. You see the ticker symbol is generated, its type is integer, but it also has an array, the stock exchange array. Then my question is, in my design, I didn't have an attribute called some kind of array. Then where does the array come from?
Multiplicity.
Multiplicity, right? So it means that the association is mapped to attributes. Is that clear? Okay, so now let me ask you another question. So suppose I delete this relationship. Or, for example, if I change the relationship, so I change it to 1. Then if I generate code again, then what do you expect to change?
Company will have a single instance of stock exchange.
Yes, so company will only have a single instance of stock exchange. Now let's see. So we go to Java and use general code. So now it's okay. Now you see the array is removed. So is that clear? Or do you have any questions for the discussion so far?
When we write that multiplicity, we are getting a normal array. If you want to update that array from array to some array list,
Yeah, definitely.
then what we have to do here? Can we do that from this tool, or do we need to manually update in the classes?
Normally, you can manually update. So if you don't like arrays, then you can change it to vector or array list or any container. Yeah. So is that clear about the meaning of association? So now what does association mean? So basically, so basically association means that you can map the association into attributes. So this is the conclusion. Associations are mapped to attributes. So is that clear? So just now I changed this one to 1. Then what if I change this one also to 1?
Only one instance.
So it means company only maintains one instance of stock exchange. Okay, any questions? So this is very important. If you still cannot follow, you can download the rational rows to generate code and do some experiments to understand it. And this is very important. So in both midterm and the final, I may give you a class diagram and ask you to implement it. So this is a very fundamental requirement, because if you want to be a qualified developer, you should be able to read the class diagram and implement it correctly. Okay, then qualifiers. So if we don't have a qualification, for example, a directory, so how would you interpret this class diagram?
A directory can have multiple files.
Okay, so a directory can have multiple files, right? So can a directory have no file? No files at all? Yes. Yeah, so asterisk means 0 or more. So it means that a directory may have many files. So this is the idea of the class diagram. Then how can you uniquely identify a file? Suppose we have a directory, then there are many files inside the directory. Then how can you uniquely identify a file?
Index.
through the file name, right? So file name is unique under a particular directory. So then for the this qualification, we can put file name here. So in this case, we reduce the multiplicity to 1. So then file name may be associated with 0 or 1 file. So don't get me wrong. Also, we reduce the multiplicity to 0 or to 1. As by nature, it is still one-to-many relationship. Is that clear? This diagram only tells you that by using the file name, you can uniquely identify a file from a set of files under the same directory. So this is the idea of qualification. So qualifiers can be used to reduce multiplicity of association. But by nature, one directory can still have many files. But since we use qualifier file name, then we can uniquely identify a file among this set of files. This is another example. If we don't ticker symbol can uniquely identify a component. Then we can move the ticker symbol to this side. Then how will you change this? We change it to 1, right? So because a ticker symbol can uniquely identify a component, but by nature, this still many-to-many relationship. In the future, if you see the qualification, then it still means many relationship. But just like the key. So if you have taken database, then a table should have a key, right? So the key can uniquely identify a record. So this is the idea. So the qualifier can uniquely identify instance of the class.
Still, is that many-to-many or many-to-one?
So by nature, it is still many-to-many. But if you use qualifier, you reduce this one to 1. It means that this ticker symbol can uniquely identify a component. But still, a stock exchange should be associated with many components. But qualifier tells you that the qualifier can uniquely identify a component.
Well, is this for only one case or?
So the use of qualification is optional. So if you don't feel comfortable, then you have to use it.
Okay.
Yeah. So qualification only gives you the additional information, just about the key. So if I give you a list of companies, then how can you uniquely identify one? That is through the ticker symbol. So that's the idea.
So it's not mandatory; it's optional. Right?
Hmm?
This qualification is not mandatory; it's optional.
Qualification is optional. So if you don't feel comfortable, you don't have to use it. The aggregation. So aggregation is a special case of association. So then what does that mean? It means that aggregation by nature is association, right? Then it has additional meaning of consists of relationship. So now we see the diamond. When we study decomposition, this is a part of relationship, right? So that's why we say it denotes consists of hierarchy. So now it'll tell me how many mufflers is associated with an exhaust system. One. How about tail pipe?
Many.
0
to
2, right? So 0 to 2. So if in the future, if you see this symbol, it means that an exhaust system consists of muffler and tailpipe. Then the multiplicity tells you, how many instances can be associated with a particular aggregate. So the aggregate is the parent class, and the components are the children classes. Then a solid diamond denotes composition. So it's something like this. In the future, you may see a diamond, but this diamond is solid. It is an even stronger form of aggregation. So composition is a stronger form of aggregation, and aggregation is a stronger form of association. So by nature, aggregation and composition are all associations, right? So composition and aggregation are all association. So, but it is a stronger form of aggregation. So in terms of the lifetime of the component instances is controlled by the aggregate. So the parts do not exist on their own. So for example, we have a ticket machine, right? So ticket machine consists of zoom button. If the ticket machine is destroyed, then the zoom button won't exist on its own. So let me give you another example. So suppose we have a person, right? So a person has head, has body, legs, and so on and so forth. So for example, if the fact that this person is dead, then the parts are also gone. So it means the lifetime of the parts depend on the lifetime of the aggregate. So if you have this relationship, then you better use composition. Otherwise, you use aggregation if it is part of relationship. And this is a very popular interview question. In the future, if you claim that you know UML, then they may ask you this question. So what's the difference between aggregation and composition? So first of all, you should be able to use right symbol. So you should know that the diamond represents either aggregation and composition. And aggregation uses a hollow diamond, and composition uses a solid diamond. And the meaning is also different. So composition is a stronger form of aggregation. So if the parts, the lifetime of parts depends on the lifetime of the aggregate, then this is composition. It means the parts cannot exist on their own. Is that clear? Okay. Then instance. So instance inheritance denotes a kind of hierarchy. So what's the symbol for inheritance? What's the symbol for inheritance?
Easy. Triangle.
Triangle, right? So for example, button. So button is the base class. Then we may have cancel button, zoom button, right? And we use the symbol of triangle with concrete line. So inheritance simplifies a analysis model by introducing a taxonomy. So the choosing classes inherit the attributes and operations of the parent class. And inheritance is even stronger than composition. So do you have any questions so far for what we discussed? The UML is very important, and you have to memorize the symbols, and you should also practice. Then package. So if you know Java programming, then package is a concept you should be familiar with. So packages help you organize UML models to increase their readability. So you can use the UML mechanism to organize classes into subsystems. So for example, we can use the package to represent a subsystem. So suppose we have a account subsystem, and we have bank subsystem, and we have customer subsystem. So you see, a subsystem may include a set of classes. So when you work on your second group assignment, which is system design, then you will use a package to represent the subsystems. So any complex system can be decomposed into subsystems. Then where each subsystem is modeled as a package. So now from now on, you have the right symbol to use to model subsystem. Okay, now let's see some examples. So class identification includes name of class, attributes, and methods. So if you see this class, then is full the right name. This is the right name. This is no. This is not right because you cannot tell from the name, so the name doesn't carry any information. So definitely we are not the babies. We don't randomly give it a name, and so the right name is account. So if you give it the name account, then people will be able to understand. So basically, we should provide the right name. So now suppose we are modeling a banking system. So we have account. Then in the first step, we find new classes. So besides account, what else we should model in a banking system? So in a banking system, you only have accounts.
Customers.
You should have customers, right? So, at least you should have customer.
Manager.
Yeah, so you may have employee. Yeah, very good.
The actual bank.
So
Like
the bank itself, very good. So now for the sake of simplicity, let's say that we only identify 3 classes. So first we identify 3 classes: bank, account, and the customer. Then we review names and attributes and methods. So do you see any problems?
There's nothing connecting the
Customer
relationship between the
account
three things.
Okay, so relationships haven't been identified yet. Yeah. So what?
No, I'm just talking about the relationships. That's it.
Okay, relationship. Yeah. Okay. So now, in next step, we'll identify the relationship. Then, do you see any errors in the current model? So,
Data types of members is not related.
which member?
Like customer IDs, whether customer is string in something like that.
Okay. Yeah. Actually, you see now the account has customer ID, right? Actually, we should rename it to account ID. So this could be a typo. So we review names, attributes, and methods. And in the next step, we will find associations between classes. So does an association relationship exist between account and the customer? Okay. Then how about account and the bank?
Yes.
Okay, so now we find associations between classes. So then we label the generic associations. So for the relationship between account and customer, we should put own. So a customer owns accounts. Then a bank has accounts. So that's okay. So these are optional. So you don't really need to label it, the relationship. But then we determine the multiplicity of the associations. So how many accounts can a customer have?
0 to many.
0 to many. So definitely you can own 0, right? You can own multiple accounts. So then how do you put it here?
Asterisk.
Asterisk. Then an account can be owned by
One customer.
one
Or
customer.
else two
Okay.
customers. Multiple customers.
Okay. Yeah. So for those who answer one customer, it means that you are not married. So then we can put up to 2, right? So then how about the bank? So how many accounts does a bank have?
So
So it can be many. Okay. Now, next step, we review associations. Then can you refine the associations? Can you refine the associations?
Do you use a qualifier?
Yeah, so we can use qualification, but it's optional. So for time being, let's just ignore that part.
Okay, we can do aggregation.
Aggregation for which association?
Customer and a bank. So a customer can have many banks. Like
We can do like a bank has a customer and customer can own any number of accounts.
Mm-hmm. Yeah. Then if you add association, aggregation, then which association? So the association between bank and account or the customer and account? Which one? Aggregation. Which one? Bank and account, right? So because the account is a part of bank, right? So then we can replace this relationship by using the aggregation. Then can you do it even further?
So then you would have a composition between customer and account. 'Cause like
Between-
you couldn't have an account without the customer.
Let's say composition between the bank and the account, because you can't have an account without a bank.
Exactly. So actually, the account can exist. The account may exist, but the relationship between customer and account is not association, is not aggregation, because account is not part of customer, right? So it doesn't, it doesn't make sense. But account is a part of bank. Then just as you mentioned, so if a bank is bankrupted, can the accounts exist on their own?
What is it? Can you repeat?
So if a bank is bankrupted, then can account exist on its own?
No.
No, not at all, right? That's why when you make a saving, you should have some kind of insurance, FDIC insurance. So we really hope that even the bank is gone, the accounts can exist on its own, but it cannot. Then we should replace the aggregation with composition. So it means that composition is a stronger form of aggregation. So if the bank is gone, then all accounts are gone. So when I just came to the United States, I opened my first checking and saving account with Washington Mutual. So I'm not sure whether you guys heard about it. So then just a few years later, Washington Mutual was gone. It was purchased by Chase. But fortunately, my accounts still exist. But the idea is nowadays you don't see any Washington Mutual. Definitely, you don't see any accounts associated with Washington Mutual. So this is the idea. So is that clear for the modeling? So in the first step, we find new classes. Then we review names, attributes, and methods. Then we find associations between classes. Then we determine the multiplicity of the associations. Then we review the associations. Then we can find taxonomies. So for account, we may have specialized accounts. For example, we may have checking, right? Then what else?
Saving.
Saving. So we may have saving account, checking account.
Current.
Yeah. So if you purchase a house, then you may have mortgage account. Then if you buy a new car, you may have the car loan and so on and so forth. So the more money you own, then the more accounts you may have. So then we can just focus on a part of the class diagram. So now you see this is the entire class diagram. Then we can just focus on the taxonomy. So we show the taxonomy separately, and we can show the top level class separately. So remember that we have 7 plus and -2 heuristics, phenomenon. So then better we make it a 5 plus or -2. So the idea is a good design doesn't tax your mind. So it makes you very comfortable to understand the idea. Okay, so do you have any questions for what we studied today? So today we reviewed use case diagram. So remember, what is an actor? What is an actor? An actor is a role. Yeah, so it is a role, and it is outside your system, right? Now, what is a use case? It represents a class of functionality, right? So it still represents a concept. So then, for a UML class, it consists of 3 parts. What are the 3 parts? UML class. Class name. Attributes. And the third part is operations. Now, which one is the only mandatory part? Class name. So you can model a class without attributes or operations. But a UML class consists of 3 parts, namely the class name, attributes, and operations. Then today we studied relationships. So what is aggregation? So what's the relationship between aggregation and association? So aggregation is a special form of association. So by nature, aggregation is also association, right? So then what makes it aggregation special? So it's a special form of association. And what makes aggregation special?
So it consists of relationship?
So it means consists of, right? Part of relationship. A regular association doesn't have this meaning. A regular association only means 2 classes are associated with each other. But aggregation means that in addition to the meaning of being associated with each other, it only has an additional meaning that it has part of relationship. Now, what's the difference between composition and aggregation?
Strong form of aggregation.
Strong form of aggregation.
So composition is a stronger form of aggregation. So by nature, it is also aggregation. So it means part of relationship. Now, what makes the composition stronger?
It can't exist without
It can't exist with aggregate.
Very good. So the parts cannot exist on their own. So the lifetime of the parts depends on the aggregate. Okay, so these are the key points of today's lecture. So do you have any questions? All right, so that's all I have. So review. So you guys need to review and keep in mind that we have the first homework assignment.
You told us to use rational construct for drawing.
You don't have to use rational rows. You can use any UML tool. So I have posted a message to Israel, so you can check. You can use any UML tools.
Using that, we need to copy this one for a second. Drawing that video and everything, we need to copy that.
Exactly. Yeah.